Welcome to Study Loop.
This is chapter 21, problem number 48. When t equals 0, the current through an inductor whose inductance is 45 millihenries is 50 milliamps, and the rate of change of current is given to us as 115 milliamps per second. And we are asked to calculate the initial potential energy. So as you know, the initial potential energy is going to be equal to 1/2 L, the inductance, times the square of the initial current. Then let's put initial here. And very straightforward calculation. L, let's convert that to henries here, 0.45 henries, right? For the milliamps, we have 0.05 amps, and let's convert this rate to amps per second. 115 times 10 to the power of -3 amps per second. Now, going back to the calculation, the initial potential energy is going to be initial current squared times the inductance divided by half. Now, the inductance is 0.45 henries, and the initial current is 0.05 amps. We're going to square that. So the initial potential energy is going to be 5.625 times 10 to the power of -4 joules. Now, we're asked to calculate the time interval that it takes for the potential energy to be 5 times of the initial potential energy. So we want the final potential energy to be 5 times the initial potential energy. Let me put PE here. Initial. And we're supposed to calculate the time interval that it takes to get to the 5 times of the initial potential energy. So first of all, let's try to do a relationship between the initial current and the final current given this equation. So the 1/2 L final current square is going to be equal to 5 times of the initial, right? So L's cancel out, it doesn't change. So then the final current square is 5 times the initial, right? So if we take the square root of both sides, then we know that the final current has to be square root of 5 times the initial current, right? So let's keep this in mind. And then in order to get the time interval, of course, we're going to have to deal with this ratio over here. So as you know, delta I means final minus initial, right? So then writing this equation, the final minus initial current divided by delta T, this is what we're looking for, is also given to us 115 times 10 to the power of -3 amps per second. And now we can plug in for the final current here in this equation. Let me do it on a new page. So then square root of 5 times the initial, right? This is the final current, times the minus the initial current, divided by delta T, then has to be equal to 115 times 10 to the power of -3 amps per second. Then if we isolate delta T out of here, then what we have is square root of 5 initial current minus initial current divided by 115 times 10 to the power of -3 amps per meter. Now let's try to organize this square root of 5 minus 1, then times the initial current is going to be equal to, divided by 115 times 10 to the power of -3 is going to be equal to the time interval that we're looking for. And we know the initial current is 0.05 amps. So square root of 5 minus 1 times 0.05 amps divided by 115 times 10 to the power of -3 amps per second. Then we're going to find our interval to be 0.537 seconds.